Hello students, welcome back to the fourth video of this playlist. So in this video, we will be solving question number 4 from the most recent past paper of Mechanics 1, that is October 2024 paper. So let's see what's the question number 4 from this latest paper is about. Okay, so you can see question number 4 on the screen. So basically the concepts behind question number 4, it's from mechanics. uh, it's related to motion, that is that has been discussed in the second chapter of your mechanics 1 textbook, which is constant acceleration. So basically we need to deal with uh, the formulas, the Suvat equations, to be more specific. We need to be uh, we will be dealing with constant acceleration formulas, the 5 formulas for Suvat equations that we know. And yeah, so let's get started with question number 4. The points A and B lie on the same straight horizontal road. Okay, fine. Figure 2 on page 11 shows the speed time graph. Okay, so page 11, where's the page 11? Okay, it's basically the next page. So okay, so this is the figure 2. We can see on the screen this is a speed time graph given. Okay, okay, so at time t equals to 0, p starts from rest at a. Okay, p starts from rest at a, accelerates uniformly for 9 seconds until his speed is v meter per second. Okay, at t equals to 0, the particle p starts from the rest and accelerates uniformly to reach a speed of v meter per second in 9 seconds. Okay, he then travels at constant speed v meter per second. Okay, we can see on the speed time graph what constant speed, it's moving for constant speed for the rest of the journey till 42 seconds. Okay, so when t equals to 42, cyclist p passes b. Okay, at t equals to 42, the cycle passes through point B. Okay, given that the distance AB is 120 meter, so the total distance from A to point B is 120 meter. Okay, so part A asks here to show that the value for V, that is the constant speed reached by the cyclist, is what? 3.2. Okay, fine. So uh, let's have a look on the speed time graph. That will let you understand the scenario of the question more better. This is a speed time graph, right? So we know that the area under the speed time graph represents what? The distance. Area under the speed time graph, it represents the distance. Okay, so since we know the total distance traveled by the what? We know the total distance traveled by the cyclist. Okay, so what we can consider, the area under this speed time graph, this is what? The area under this speed time graph is equals to that given distance, which is 120 meter. Okay, so uh, okay, so we can divide the speed time graph into two parts. This is one area and this is what? The first one is triangle and this is rectangle. Okay, so look, the area of the triangle is what? 9 over what? 2. Half into base is 9, so 9 half times 9, this is 9 over 2 v plus what? The area of the rectangle is 42 minus 9, which is 33. 33 times v, so 33 v, this is equals to 120. Fine, so we need the value for v. So if you make the v the subject, so what you will get? 120 120 over, So 120 over 33 plus 4.5, that is basically 37.5. So that would give you the value for V is 120 over 37.5, that is 3.2. 3.2, and that's exactly what uh, question 3 question 4a has asked for. Okay, next is part B. So in part B, they're asking to find the acceleration of cyclist P between t equals to 0 to t equals to 9. Okay, fine. So we need to find out the rate for increase of speed. That is the acceleration that has been occurred for this cyclist P from t equals to 0 to time what 9 seconds. So this is what, this is basically the gradient of the speed time graph, because acceleration is what, the rate of increase of what, rate of change of speed or rate of change of velocity, right? So just we will find out the gradient of the speed time graph to get the acceleration. So uh, acceleration, that would be what, a would be v minus u. V is 3.2 minus 0 over time. Time is what, 9. So we will get the acceleration 3.2 over 9. That would give you a 16 over 45 meter per second squared. So we can give this value to three significant figures as it's in standard. So this is basically 0.356 meter per second squared. Okay, this is up to three significant figures, and that's what part B of question number 4 has asked for. Okay, next is part B. Cyclist P continues to cycle along the road in the same direction at the same constant speed v meter per second. Okay, fine. When t equals to 6, a second cyclist Q sets off from A and travels in the same direction as P along the same road. Okay. Another cyclist Q, it starts its journey at t equals to 6 second and from the same position as cyclist P where it has started from. Okay, she accelerates for t seconds until her speed is 3.6 meter per second. Okay, so she then travels at constant speed 3.6 meter per second. Cyclist Q catches up with P when t equals 54. Okay, when t equals to 54, cyclist Q, she catches up the first cyclist, which is cyclist P. Okay, so part C asks here on figure 2 on page 11, sketch a speed time graph showing the journeys of both cyclists for the interval 0 to what, 54. Okay, so figure 11, sorry, figure 2 on page 11. Okay, so on figure 2 we need to sketch the speed time graph for the what, cyclist Q. Cyclist, for cyclist P it's already given, we need to sketch for cyclist P, cyclist Q. Okay, so speed time graph, we know that the cyclist Q started from t equals to 6, so it will be before 9, starting from before 9. Okay, it starts from there. This is 6 t equals to 6, and cyclist Q accelerates for t seconds, we don't know the value for t, to reach a speed of 3.6 meter per second. Okay, so accelerates, right? So okay, it shouldn't be dotted line, it should be a solid line. Okay, so it starts from there, it will be accelerating. Will it be parallel or steeper? Definitely it will be more steeper than the acceleration, the speed time graph of the cyclist P, because it is reaching a greater speed, isn't it? So since it's reaching a greater speed, so it will reach, it will be more steeper, the speed time graph, while acceleration. Okay, so this is what, 3.6, and then it moved at a constant at that constant speed till t equals to what? 54. Okay, so this is what? This is basically 54, and this is what? One is v, the other one is for what? 36, isn't it? This is not 36, it's 3.6 meter per second. Okay, and 54. Okay, we need to uh, enlarge the speed time graph of the what? Of the cyclist P, because they also wanted that one, right? Okay, so this would be till this. Okay, because for till t equals to 54 second, the cyclist P has moved with the same constant speed, so it will be a horizontal straight line till t equals to 54, and that's the sketch that is wanted by the question 4C. Fine. Okay, next is part D, the last part of question number 4 from M1 October 2024 paper. So they are asking to find the value of t. We need to find out the value for what? T. Okay, so to find out the value for t, okay, I didn't uh, labeled this part. This part is basically what? Okay, it should be a dotted line. Okay, so this part will be what? 6 plus t. Fine, that would be 6 plus t, because for t seconds it has accelerated, isn't it? So this will be 6. Okay, so this is what? 6 plus t. This time is 6 plus t. I didn't label it earlier in part B. Okay, this is 6 plus t. Fine. So the cyclist Q has accelerated for t seconds and then reached 3.6 meter per second. And she catched up the cyclist P at t equals to 54. And since both the cyclists has started from the same starting point, okay, from the same starting point, that is A, that's why the total distance traveled by cyclist P in this 54 seconds, and for cyclist Q it will be 54 minus 6, which is 48 seconds, will be equal. The total distance traveled by both the cyclist P and Q in this t equals to 54 second will be what? Equal. Okay, so okay, fine. For part D, okay, the earlier one was part C. That one, the sketch was for part C. Okay, the area under the graph for both the what? Cyclist will be equal. Okay, so for cyclist P, the total area under the graph would be what? We know that till t equals to 42, the total distance is 120. We did this earlier in part A. We considered, look, the total distance is what? 120 till t equals to 42. So till t equals to 54, we need to consider this area, right? We need to consider this area. So this area is what? Vt. 54 minus 42, this is what? 12. So total distance for cyclist P, this is 120 plus Vt. Vt is what? 54 minus 42. You can show the working. 54 minus 42 times 3.2. So this is equal to what? So this is equal to the total distance traveled by the cyclist Q. So total distance traveled by cyclist Q is the area under speed time graph. Okay, So the first area, this is what? This is a triangle. So half times base times height. So base is what? 6, just t. Okay. So half of base is t times height is what? Height is the velocity, the speed reached, which is 3.6 plus vt. So v is 3.6 times t is what? T is 54 minus 6 minus t, because uh, after t equals to 6 plus t seconds, the particle, the cyclist q is moving with the constant speed for the rest of the time, isn't it? Till t equals to 54. So time would be 54 minus 6 minus t. That's it. Okay. So now just calculate, just solve this equation. 54 minus 42, that is 12. 12 times 3.2, this is 38.4. So 38.4 equals 3.6 times half, that is 1.8, 1.8t plus 3.6 times 54, that is 194.4, 194.4. Okay, wait, 54 minus 6 is 48. Let's simplify it. 48 times 3.6, that would give you 172 point what? 8 minus 3.6 capital T. Okay, now we need to make t the subject. So take all the constants on one side and all the uh, terms with t on the other side. So you'll get negative 1.8 t on the right side, so take it to the right. Take it to the left, so it will become positive 1.8 t, and take these constants to the other side. The other side is basically the right side. 172.8 minus 120 minus 38.4. Okay, this is 14.4. 14.4. Okay, so the value for t is what? 14.4 over 1.8, that would give you exactly 8. So the value of t is exactly 8. And that's what exactly part D of question number 4 from M1 October 2024 paper has asked for. And that's the end of question number 4. Fine.